Okay, so on page 9, we just have these last two questions. So let's look at part D. So the first thing you want to do is look at each parameter individually to determine your domain restriction. And this one is this one has two red lights in one. It has a square root, and the square root is in the denominator. Normally with the square root, we would say it could equal 0. But because this is in the denominator, t has to be greater. It has to be greater than 0. It cannot equal 0. So we can't put that equal sign that we normally would because of where it's located. And then our second one has a t in our denominator, so t cannot equal 0. So this actually takes care of this one because we already established that it couldn't equal 0 in this first one. All right, so let's get started. So now that we have that, we know that this is at minimum our domain, and we'll see if we need to add anything else to it. So the first thing we're going to do, take our x, solve it for t. So I think the easiest way to go about doing that is to multiply both sides by the square root of t, because that's going to cancel out the t, the square root of t. And that's going to leave you with x times the square root of t equals 1. And what do you think we're going to do next to solve for t? What else? What do we have to do? Well, before we square it, we need to get rid of x. So how do I get rid of x? If it's being multiplied by the square root of t, divide both sides by x. So then that's going to leave you with the square root of t equals 1 over x. And now we can square it. And I'm going to square the t, I'm squaring the 1, and I'm squaring the x, which is just going to leave you with t equals 1 over x squared. So I'm going to take that. And now we're ready to substitute that in my y parameter. But notice that y has t in two places. So when I substitute that 1 over x squared, I'm putting it here and here. Okay, so that's going to give you y equals, and then I have 1 over x squared plus 1 over 1 over x squared. So I'm going to pause right there so you all can see. So remember, you just have one more test, a project. Going into the final, you want to have at least a strong 75. That's your goal. So, any questions about how we made it to this step? Okay, so we actually were going to do our keep, change, flip. So I'm going to keep this, and I'm changing that division to a multiplication, and I'm flipping this. So let's do our keep, change, flip. So y equals 1 over x squared plus 1. So that goes, and then I'm multiplying that keep, change by x squared over 1. Or really just x squared. You're just multiplying it by x squared, because x squared over 1 is just x squared. All right, so now you're ready to multiply. So you're multiplying both of these by x squared. And when you multiply 1 over x squared by x squared over 1, how do you multiply fractions? You just go across. So this will be 1 times x squared over x squared times 1. So I have y equals x squared over x squared plus x squared. So let me review that again just to make sure we all got that. So I'm taking this fraction and I'm multiplying it by this first. And when you multiply fractions, you just go multiply numerator times numerator and denominator times denominator. So I'm multiplying 1 times x squared, which gives me x squared, over x squared times 1, which is still x squared. That's how I got this. And then here, I didn't put the 1 at the bottom. I mean, you can if you really want to hold on to that denominator of 1, but you know, you don't have to. When I multiplied this by this, I just got x squared. All right, what do you think this is going to simplify down to, though? Yep, because anything divided against itself is 1. 3 divided by 3 is 1. 10 divided by 10 is 1. X divided by x is 1. X squared divided by x squared is 1. So your final equation is simply y equals 1 plus x squared. And in that equation, do I have any restrictions? Do I have a square root or an x in the denominator? Do I have any red lights in my box? So my only restrictions are what I started off with, which is t has to be greater than 0 and t cannot equal 0. So my domain restriction would be x has to be greater than 0, and written in interval notation, that would be a parentheses on the 0 to infinity. So that would be my final equation and its domain. Any questions about how we work through that? Let me go ahead and zoom in for that. I'll zoom out. All right, so now let's go ahead and make your table. We'll finish this out. We'll do our graph. Go ahead and create this table. And again, we're using the interval which said -2 to 2. And that's why we did -2 to 2. So I'll give you a minute to take a few minutes to find these 10 numbers. So you're going to use these 5 numbers in your x parameter. So you're going to square these 5 numbers to get x. And then you're going to cube these 5 numbers to get y. So I'm going to freeze my screen. And I'm going to work it out and you work it out also. And we'll see if we get the same thing. All right, who has all 10 numbers? Anybody still working on them, on the 10 numbers? All right, who agrees with my numbers? Who had those same numbers that I had? All right, let's go ahead and graph it out. And I just counted every other one, so. And then make sure you add your arrows to show the direction of the curve. So this curve began down here at 4, -8, and then it traveled up and out. So that's the direction. So you only need to put a few of those little arrows on there. Let me make my arrows a little bolder so you can see them. And that's it. All right, use this time. You should have the entire first 2 pages of homework 16 done. Remember, that one is a double homework, essentially. I could have separated it in 2 pages, but I just made it one packet. So you should have the first 2 pages finished. And then tomorrow we'll start working on word problems.